Hello everyone, welcome to Twilio Quest Tuesday. It is Press X to Learn, our stream where we play coding and educational video games and talk about how they do what they do and what we can learn from it for Twilio Quest. Welcome, welcome, welcome. Hi Psych, thanks for joining us. My name is Joe and I'm one of your hosts today. Let me add on my co-host. Welcome to the screen. How are you doing today?
I'm good, how are you?
I'm
eating breakfast, so apologies.
It's perfect. I'll equalize the score by eating this cookie. There we go. What are we here to do today?
We're playing a video game, and we're going to talk about it.
Excellent.
It's called Human Resource Machine.
Mm-hmm. Which I'm very excited about. We'll talk about who this dev is. Have you played any of their games before?
I have played Human Resource Machine on my phone,
Perfect.
which is actually surprisingly good. I don't think I've
yes.
ever played a programming game successfully on a phone before. I guess I've never tried because it sounds awful, but it was actually pretty sweet.
Yeah, it is very good. Perfect, so we'll talk about that. But before we get into that, what have you been playing recently, Ryan? Oh no, is it so bad?
I timed it horribly. I was like, all right.
Oh, right, get some breakfast in. Get some breakfast
in. And then you immediately throw it back. Yeah.
Sorry.
No, it's fine.
No breakfast on my stream.
Talk. God, and now after all of that nonsense, I have totally forgotten what I'm even playing. So this is just doubly bad.
Really?
Well, okay, I can't remember what I was playing, but this past weekend, I watched an Age of Empires 2 tournament. So that was a fun time. It's very weird to feel like I'm watching sports now. Like I'm now old enough that I'm just watching sports on the weekends.
Is that
they're
why
just weird sports?
Yeah. Is that why Day 9 has been playing loads of Age of Empires 2 again? Was he in the tournament, or is he just doing that related?
No, he I think it just happened to coincide. Like Age of Empires 2 has like a he played a bunch of it last year or something.
Yeah, he did. Yeah, before Age of Empires 4 came out.
Right, yeah. So that was like the hype lead up, but I think Red Bull is sponsoring a bunch of money to like a big tournament this year, and so that probably has something to do with like renewed interest.
Right. That makes sense. Awesome. I sunk my teeth into Last Call BBS, which I know you had played on the last stream. Oh, and I know I messaged you about this.
Good.
Like, not even just a game, and a full experience. Like, I full-on guffawed when, for those of you who don't know, Last Call BBS is the last game from Zachtronics, who we featured many times on the show, and had Zach on himself. And Last Call BBS is actually a collection of games that all take place on a retro computer called the Z5 Power Lance, and you download them via connecting to the Last Call BBS, like an old-school BBS system. And that is hilarious because there's a simulated download. So when you go and download the games, there's a simulated download, which takes a long time. Then there's a download limit. So I went to stream. I actually streamed it on another channel.
Oh, nice.
And I was like, Zach's got me. After all this time, he's finally forced me to learn how to play solitaire in one of his blasted games. And I had to sit there and learn solitaire whilst waiting for my game to download.
Yeah.
And then, it was great.
I really liked that because every time I play one of their games, I'm always like, oh, it would be fun to play the solitaire. Like, I'll come back to that. And then it's literally never happened in my whole life. But this time he was like, no,
and
listen,
all the
that's
games
all
in
you
it
can do.
are like, there's none of like the assembly What I've encountered. I guess I haven't played the circuit one yet, but they're all obviously kind of programming related, but like interesting ways. Like 20th Century Food Court is a lot like Signal State, which like analog electronics. It's like Signal State mixed Factorio, which is really interesting. By cat. Cat's been banished. Banish the cat. The daily ritual. And then there's the weird like Eldritch Flesh programming game that's kind of like programming cellular automata. That was really cool. That was a little bit like... This is kind of the thing I really like about a lot of their games, where it feels like... That one in particular feels like... Approach like a classic computer science thing, such as Conway's Game of Life, and work out how you make a Zachtronics game out of it. It was really cool. So I enjoyed it a lot.
Yeah, that's what I really liked a lot about that experience, was that there's so many of these things where you're like, if you had to make the cellular automata Flesh game into a full feature-length thing, I feel like you might grow to hate it. But a lot of these were just like, just enough where you could be here's this weird thing, like the circuit one is another one where it's just like, this is my electrical engineering. Like I had this class like many years ago, and if this were longer, this would suck. But right now I'm like, oh yeah, I remember this enough, sort of.
Yeah. And although it feels really silly because we can literally do this anytime in a computer game, like if I get stuck on one of those games, I just nip out and go do hack a match for a bit, which like just is a really nice experience.
Yeah, it's very cool.
So yeah. So we are here to play Human Resource Machine today. So let me throw up my screen and change over the music. So Human Resource Machine. Can you hear audio?
I do.
Very different change of pace. So Human Resource Machine is the first of two kind of programming games by the Tomorrow Corporation. The Tomorrow Corporation is a little indie dev outfit. There's, I think, 3 developers. And I first encountered them in, I think it was their first game called World of Goo, which was a puzzle game, but was like a building puzzle game. So you had these little goo balls that would connect to each other via goo tendrils, and you had to build structures. And that I really enjoyed that game, and so Human Resource Machine came out. And all of their games are kind of set in a dystopic world ruled by... typical like company rules the world kind of thing. That's the Tomorrow Corporation, and they're all a little bit dark. Like their game that came out between World of Goo and this was called Little Inferno, which was a really bizarre game. You had a fireplace sold to you by the company called the Little Inferno, and it was like a productized fireplace, but the whole thing was like you have no energy and no heating, and so like it gamifies you feeding your worldly possessions into the Little Inferno to keep yourself warm and alive, and you unlock things for burning stuff. And so Human Resource Machine is kind of in that dystopic vein, where it is a programming puzzle game, as Psych is conveniently saying in chat, that could arguably be called to be in the Zack-like genre, but what you are programming is the actions of meaningless office drones, and in that vein, let's begin playing the game. And one of the ways I think it's really fun how the game enforces this. So I'll create a new save, right? So please select your employee ID. I have your photo here. Which one is yours? You only get 4 characters to choose from, and you choose one, and then it's like, cool, you're employee 2. And so like from the out, it's like you are, no customization, no name even. It's just you are a faceless drone, get to work, which I think was just like a really nice little touch. And so this game is like really, and this is true of all the Tomorrow Corporation games, but like super charming and super like well done aesthetically. Like we're in the elevator here to choose the floor we're going to. We've got coffee stains on the wall, run down stuff, random stuff stuck to it. We can see the tree of all the skills and stuff.
Wow, I never scrolled up.
Yeah, it's long. To your point, all their games are available on like every platform imaginable, and the mobile. So I said this is one of 2 games. Human Resource is the first one, and 7 Billion Humans is the second one. And 7 Billion Humans is definitely like a spiritual... Well, I don't think spiritual. I think it's just a direct sequel. And we might do 7 Billion Humans in future, or maybe we'll open it somewhere here. But the main difference between the two is in this game, you're predominantly programming like one office worker, and then 7 Billion Humans is all about like programming lots of them at the same time.
Oh yeah, just like going to the page, I just see hordes.
Yeah,
and I'm like,
yeah,
that's compelling though. That's cool.
Yeah, right. It's a really cool progression between the games. And I'm gonna, as we go into this game, I think the thing I'm going to seed on here is like, unlike the Zachtronics games that use assembly language, I mean the Zachtronics games use assembly language. Yes, they're not necessarily aimed at programmers, but obviously like programmers are more familiar with that and going to get instant enjoyment out of it. This game definitely feels like from the outset it is doing a lot to introduce the concepts of computational thinking, because it makes for satisfying puzzle mechanics. And I differentiate that from like the assembly games from Zachtronics in that like they are for people who know that programming problems are interesting and want to do it in a game. This is for like this is introducing computational thinking as a mechanic first of all. So that is kind of like one thing I felt about it. But anyway, let's jump into
what I think is pretty interesting about it too, though, is that this is still assembly basically. Like they because I was thinking about that too, and I was like, oh yeah, this is much more accessible. But it's like I guess it makes sense because like you're saying, it's logic, and they're trying to basic building blocks. You know, you can't jump into like the entirety of a complex language. But I was just like, oh, interesting that it's accessible, but also just like I'm getting a jump if not equal was like assembly like 101. I thought that was pretty interesting. It definitely feels like a puzzle pieces though versus like opening up my downloaded PDF manual on
your connection is really choppy, but that all came through. But just to warn you.
Okay.
I don't know if there's anything you can do about that. We're having technical difficulties today, chat. So straight away we get our manager telling us we look like an excellent instruction follower. We'll get our first job on the right. Remember, you can always ask them for help, and this is actually really key. This fellow does some cool stuff, and as Ryan said, we get this kind of coding interface that will start to look a lot like assembly. But right now we have our inputs, which is this conveyor belt on the left, our inbox, and our outputs. And this in itself is kind of interesting. We'll come back more to like they actually play with the fact these are conveyor belts and that the fact they work like a stack. It's first in, first out. And so like they do play with that. We do have the ability to like, we can put something in, we can copy that, we can paste the whole program again. So it's really easy to copy and program paste this out. We, as with Zachtronics, we have a way to step through our program and a way to speed it up and slow it down. But in this one, really simple. We just need to take boxes off the input and put them to the output.
That little effect too was great. If you like pull the outbox back off.
Yeah, the wiggling.
It's just like really walking you through. Like this drag and drop. Yeah, this stuff's great.
Yeah. And this is wiggling, obviously, so we're plus run. And I've only done this. We got an arrow telling us where in the execution we are. And obviously I've done it once. And so we get told by our little management dude that 3 items need to be there. And then we get to step back and debug and see what went wrong, or we can stop and reset. So I really like, again, like, I think they build this up really, really nicely. Obviously, we're meant to repeat these instructions, which is already leading into like, oh, this feels like a lot of repetition. I wonder what's going to be next, kind of thing, which is cool. So actually, before I do that, you see this dude's got the exclamation mark. He always provides helpful stuff. So you can ask him to repeat the initial instruction, but then you can ask for more information. So he'll explain what's currently happening in the level, so you can put together a list of commands over there on the right side, and then walks you through it. One that I think is really cool is, can you give me an example? Oh my god, this text goes on for a long time. Can you give me an example where it's literally just like, here's your input and your output should be this, which is just like a test case really, which is really like clear and concise. And it's kind of fun how they have. Yeah, go ahead.
No. Yeah, I was gonna say, like, this is yet one more game that has like that piece of information very clear in its own special location, right? Like we've started doing that in Twilio Quest, where we just kind of have bulleted lists of examples, but like people miss one or slightly misinterpret, or like there's just every single one of these that we play is like, here is all the pieces of information presented in as little words as possible in a very clear place, and it's the same way every time. So
absolutely. One
more vote for that. Am I still cutting out?
You're a bit better, actually. It's mainly your video. Your audio, I think, is fine, but yeah, it looks like it's okay now. So yeah, I'm just going to click run, and you see our little dude doing the thing. And then off goes our output. And we get our obnoxiously loud cheering. These hands kind of weird me out a little bit. I don't like that they've applied skin texture to the hands.
That's what I think is really fun about their art is like that. Yeah. That line of like adorable, creepy, like I don't know what you call that aesthetic.
Yeah, it's like almost Tim Burton-esque in places. Like
I can see that. Yeah.
Okay. Syke says, very cool game and nice animation. It is super nice. So they can tell we have a bright future in inbox, outbox management. Here's your next assignment. Grab each thing from the inbox and drop each one into the outbox. We have a new command. We now have jump. With this new ability, you complete the assignment using only 3 total commands. So again, I like this, that they're explicitly, telling us we've got a lot more input here. So straight away, using what we did the last lesson, just stacking inbox and outbox looks really intimidating. And they're explicitly telling us here that we only need to use 3 commands, which I think is really cool. So I'm going to throw jump in, and jump kind of does this interesting thing. Go ahead.
I was just one thing that I thought was hilarious is like, because there's like a character here, I like read jump and I was like, why is my character going to jump? Like I literally was which is funny because I know jump as an assembly term, and I just like saw that. I was like, oh, the character's gonna jump over holes in the floor or something.
Yeah,
which was pretty funny.
That's actually something which I think is, and I haven't quite got to a coherent thought on this yet, but I think there's something interesting about
jump is like go-to psych. There's a little bit more. I think go-to maybe doesn't do quite as many things as the future jump commands will, but yeah, you can think of it like go-to.
But yeah, there's a kind of interesting thing where, like, you know, in some ways this is like a stack-based programming language, right? Like we've got some stuff on the stack, we're manipulating it and putting it on the output. But all of our programs, all of our instructions manipulate this dude, and like it's all about this dude moving data around. So like it's a really interesting computing paradigm, and like I guess it's kind of like, you know, in the assembly games, it's kind of like when you're having to manage putting things onto the stacks, not the stacks, sorry, into the registers and not. But like, I mean, we do get more later, but I mean, it's just kind of fun that like this, we're programming this pointer, and this pointer kind of moves around and does stuff. This one takes a while, so it's good. Go ahead.
Yeah, you've also talked about, they also teach you to use the speed up button here, which is,
they do.
Which is pretty clever. Oh god. Oh, so you've talked about before about how you kind of see a lot of, it's pretty common to have like the agential programming versus the like write a programming game. I don't know if that.
Sorry, that broke up a little bit. It's very common.
Perfect, because I used a bunch of dumb words. We've talked about before about like the split between like kind of like agential, like programming a robot to do a thing, and then like writing a script that does this thing. And I think this one's interesting because it's like we are doing the script approach, but there is that. We
are actually programming an actor, and I do think that like, and they lean into it a bit, like that becomes more important in the later levels here. But I think like they had that realization whilst they were thinking about 7 billion humans, because obviously 7 billion humans takes that to the extreme, where like here there is a dude, but that dude is, as I said, like basically an abstraction for a single
visual
register.
Debugger.
Whereas in 7 billion humans, programming a bunch of agents does actually become the point, whereas here the agent is just an abstraction, right?
Interesting.
Which is kind of cool. We're gonna have to end up opening 7 billion humans.
We're using jump as a loop there. But there's going to be some conditional jumps we can do later and start getting into fancy things.
And so now this one is really cool. It gives us another place to store data. So we've only had the input and output. The input's broken, we've just got a bunch of 99s, but our output needs to be bug. And so here we get the space on the floor, and what's really cool here is we can use copy froms. And these copy froms are just like arrays. So each of these space on the floor is numbered, and we can just kind of choose which one we want to access. So we could do like that, for example, but then each of these needs to go to the outbox. So in this one, our dude's going to grab the B, take it over to out, grab the U, take it over to out, and then grab the G and take it over to out. So you end up with this kind of secondary space, which is now where like this is like literally just like, well, I mean, it's kind of accessed like an array, but it's like a register space, I guess. And we really see that in this one where we have to take input off the belt and then rearrange it before going to the output. There was one thing I forgot to show actually, so I'm going to quickly go back and do it. On the looping, this is, I think, the one where his dialogue is like, again, this is the one that made me think like, oh, they're really hitting on just like some computational thinking and stuff here. You asked, tell me more on this one, and they're just like, oh, jump is really powerful. Just like straight away, like allows you to do like, you know, you can skip entire sections, you can use it to loop. Like they just really introduce it as like an interesting primitive, right? In a very kind of high level way, which I think is really cool.
Yeah, that's a good touch. That's something that we've talked about with Twilio Quest. With Nicole joining us, so we're talking about like going back and like enriching like, because a lot of Twilio Quest content right now is pretty like focused on the content itself. But we're talking about enriching spaces, similar to how I actually did with the second section of the API Academy. We have like those portraits and the statues, just kind of
which is so
hints
cool.
and yeah, context and stuff like that. Where it's just like, I heard the jump command is pretty sick, and you're like, oh, I should check out the jump command. Yeah, that stuff's great.
Speaking of Nicole, I did see Nicole in chat. Hi, Nicole. Okay, so now the conveyor system is fixed, and we need to get back to work. So data here won't collect itself. Here we need to grab two things, and then reverse them to go into the outbox. This obviously isn't something that we can do, because you can only ever grab the top thing from the input, so it's not something we can do without using the middle space. And so what it wants you to do here is copy to, and we'll, inbox. So grab an item from the inbox, copy it to the array, grab the next item from inbox, copy it to the array, and put it in another space, and then we reverse that operation. So we grab 1 and put it in outbox, and we grab 0 and put it in outbox, and then we need to do it for the whole list, and so then we loop it. This is one of the ones where, and I think this happens in every programming game at least once, where like suddenly it feels like, if you're thinking about this from the perspective of someone who's never programmed before, this one feels like a very sudden escalation, in that not only is it introducing copying to, but you then need to combine that with a loop in one step, and that actually does feel like quite a lot to me. Maybe I'm being too pessimistic.
Yeah, I think it's weird because this didn't really need to jump. Like, yeah, I guess that's
they could have done a shorter input list to start with, right? Like,
yeah. But I think that they set themselves up to make this kind of hard with output being like, there's no way to like copying to is not something that they can test on, because outbox is the only. So it's interesting.
Yeah. It's also interesting, and again, I don't really have a fully formed thought on this, but like as a language, as a model, it's interesting that we take items from input and put items into output, but we only copy to or copy from the array in the middle. Like, those things are ephemeral and don't really exist. Like, you can make, and obviously something they use later on, you can make like 1 million copies of something in the middle, but it gets destroyed in the input and output queue. Okay, and then these coffee times are kind of just like narrative beats, which again we've spoken about 1 million times. Yeah, in all these games introducing some narrative.
But like weirdly HD fridge that's also kind of wrong, and the like strange.
Yeah,
the vibe is just very good and very
absolutely cursed.
Yeah,
like everything's sepia. Like yeah. It really gives you and even just like the lens, like the flare around or the shadow around the outside, to make it feel like there's an apocalypse going on.
Yeah. Sykes asking about the carpet, like the space buffer thing. Yeah, that's kind of like we briefly mentioned it. We were thinking about it as kind of like a memory array, but like a space buffer is I think that kind of makes sense to think of it that way too.
Yeah, that's definitely the role it's playing, and then they're doing it kind of like array accessing, which is interesting. Copy to is different from move to. Yes, copy to is different. We actually don't get a move to. There anyway. So yeah,
that's
they
what's
also kind of
about that.
Yeah.
No, I was just say that is the interesting thing, is that like we're programming this agent and like you might expect a move to, but that's not like
right.
Or I guess copy. Yeah. Anyway, it's fine. We don't get that anywhere I've gotten to anyway. Move to does make sense though.
This is nice. I hear you don't actually need to know very much about math to complete these assignments. I guess that's like... It'd be interesting... I'd love to know where the origin of that particular piece of dialogue... Like, a big list of numbers has just appeared, and we've now got a numeric command for adding. Yeah. And I wonder if like they actually put that in response from like early feedback or like horror from people. Do a good job. Our careers depend on this. See, that's like one of the... like. There's like a less useful... piece of dialogue, like tell me more in some missions, tells you more about the new command you've just been given. That one doesn't really help. Okay, so for each two things in the outbox, go ahead.
I think that's still nice though. Like, I think that sometimes we can end up with doing nothing because we're like, I don't have anything meaningful or impactful to say about the add command right now that you're not going to learn. And so we kind of lead up to the situation where it's like, you can just put something. Like, it doesn't have to be, not everything has to be profound, I guess. Like, there's still value in that silly quip, you know? Like, I think that's interesting.
And they kind of have the forcing function here where, like, you know, we have that open space and we just don't necessarily have an NPC in that place on the map, whereas every level that dude needs to be there and he needs to have something to say.
And we spend so much, we cram so much information into the objectives that it's like there's not really a good place for, like, we try to do it sometimes, like put some more expressive, like Cedric's looking for his YouTube video kind of context in our objectives, but it's not like this dude has a spot where that happens every time.
I think one thing I've been thinking, like the mobile, like talking about the mobile version is a really it's really interesting for this game, because you were saying, like, you know, you haven't played any of these games on mobile. One of my personal soapbox pet peeves, whatever, is just that the experience of actually writing code on mobile is still so terrible. Like, and there's a couple of like reasons for that. One of them is, like, you know, iOS has been very locked down, and so you couldn't have like language compilers, interpreters on the phone, and so it was always kind of, even if you wrote the code, it was like, you know, what were you then going to do with it? Send it to SSH somewhere, whatever. But that's now kind of changed a bit. But even then, like, even when you get, there's a really great developer who recently stepped into the text editor space and made a text editor for iOS. It's nice enough, but like, it is still just predominantly like a desktop text editor put on a small screen, and like no one ever plays with like, what does touchscreen bring to this? What does the small screen bring to this? And I think about that a lot with what, like, you know, we spoke about a couple of times with like the UI of these games and how they try to get everything on one screen and how they succeed in doing that. And this game's a really good example of that, I think, because like there's a lot, you know, they've got to have the space for like the little guy to move around, and they've got to have both the input and the output and the array buffer. They've got to have the command list, but it's a very enjoyable experience still. And so is 7 Billion Humans, which is equally complex.
Well, and the thing that's particularly clever about, like, you're talking about using the phone to like its own ability, like the thing that they do on at least the version that I have of this is like when you like you hold your phone this way, but you can actually turn it vertical, and like
to get a longer list.
The text and stuff actually full screen like covers up the map, like the field, so you can like mess with that and then like turn it back to look. So they actually like make use of like,
really cool.
It's really cool. I was like,
I don't think 7 Billion Humans does that. I've only played 7 Billion Humans on mobile, but I don't think that one does that. Maybe it does.
It might be newer too. Really, I don't know. I mean, I just downloaded it yesterday. So
that's really cool.
It's pretty sweet feature.
I have CraftOS Psych, and that is also very good. So like this situation has for iOS has changed a little bit. There's now a lot more native interpreters. This is completely what
the Computer Craft OS is on iOS, like that's
someone built a full iOS emulator of it, and this is actually true of this is a thing that happens in quite a few things. So someone built an emulator of CraftOS, and then like someone's like, oh, someone's built an emulator of this computing system. It has a shell and stuff. So when I want to, you know, have a programming environment on my iOS phone, I'll build on top of that. And the same thing happened with Pythonista. So Pythonista was like a Python emulator built for iPhone, and it had a Python REPL. And so someone then wrote a terminal emulator for the Pythonista Python REPL, so they ported Bash to it, and then someone ported the packet, like a package manager, to that. And now, if you want to use Unix on your iPhone, Pythonista basically has everything, because BusyBox has been ported to it. And so you can download Pythonista, the Python app, download the terminal emulator for the Python REPL, and then you've just got Unix on your phone. Like, it's ridiculous. And CraftOS has kind of got a similar trajectory.
Oh man.
Yeah.
That's hilarious.
Yeah. But anyway, let's do some math. So each two things. So straight away, we're going to be using the buffer area again. But this is kind of fun, I think, in that add, you would expect, well, I would expect, that add will add two things on the floor. No, add uses one thing on the floor and one thing you're holding. So let's grab something and then copy it to 0. And then we grab something and then we add. And let's see how that runs.
This was definitely one thing that I would like. I tried for. This is always an issue with these kinds of games. where you're like, I don't know exactly how this is going to work. Like I see that it's literally describing that now.
Yeah.
But I definitely kind of like lost that.
Yeah,
but it ended up fine. I just played it, and tried it out.
Right.
I think
which I think like it makes it fairly
to,
safe to experiment. Yeah.
Yeah. The game's encouraging you to like just experiment is good. Yeah. I think.
But this is definitely like, again, like the addition operator working on something you're holding and something on the floor rather than just two things on the floor. Like, it could very easily work like, like this add command could take two parameters. Could even take three parameters, like two spaces and then the third one where it will put the contents. And then you could copy from that. I guess this results in shorter code. We don't have to do the extra copy from. But does it result in more intuitive code? I don't know. And this is again an interesting thing about this dude being an abstraction for like a pointer, right? Which is.
Well, I guess he's sort of like the accumulator.
Yeah.
A little bit.
Yeah.
But he's moving, which is weird.
He's a little fold.
I mean, I guess in a way he's more of a register than a pointer.
Yeah.
Anyway,
his role changes a little bit as well. Yeah.
Yeah, this is part of where I don't expect new programmers to think or care about anything we're talking about. And this is one of those places where, like, when you start thinking about it too hard, you like confuse yourself.
But I mean, it's really interesting.
Is this little man
to me
an accumulator, or is he? People are just like, he carries the stuff.
Yeah. Well, it's really interesting for me because, like, as we were talking about the Zachtronics game with the horrible Flesh game. There's like, how you come about the design of these games is like, I think with these programming games especially, like, it would be impossible to conceptualize these puzzles without conceptualizing the machine, right? So like, it feels like you need to have chosen, and again, I don't know, so that if I had actually remembered anything from Zach's book, maybe there's an answer to this in there, but like, it feels like you always need to like build your virtual machine for the game and then work out the mechanics, or like how that makes mechanics interesting, and then tweak the design of the machine. And so that's where I think, like, for our purposes, not necessarily for players, for our purposes, like, what does this dude represent in a virtual machine and in this language is like key to how that works in the design, right? So this game delineates kind of stages by the color of the buttons, so we could go on and keep doing this difficulty, but I think let's jump into the blue. And if I remember correctly from this is where we start to get Zachtronic style optimization things in now, where we get two options for like meeting the spec based on the number of instructions and also executing in a given amount of time. Where do you see yourself for 5 years or 10 years? From this point on, your performance will be evaluated with extra scrutiny. What a treat. Okay. Send all the things that are not 0 to the outbox. And this is where we get the conditional jumps, as you were saying. You got a new command. It jumps only if the value we're holding is 0. Otherwise, it continues to the next line. Okay. So, let's grab something from the inbox. If the value we're holding is 0. So, we want to jump if 0 to... Wait, how do we just get rid of it? How do we get rid of something we're holding?
If you just pick something else
another thing up?
You'll just overwrite it. Yeah.
Perfect. Okay. Great. So that's easy. That's easy enough.
The old
boom. Beta. Yeah. So literally just that then. Oh, I need next jump. Yeah.
Yeah.
Go us.
Get out of here, zeros.
That was a nice little introduction to that conditional block. And here we get our first look at these data. So use 4 or fewer commands. We've done that. Do it in 23 or fewer steps. We've done that.
Jump if 0 is very assembly psych. That is like a fundamental assembly command.
For sure. Again, a nice kind of tutorialization note here. It's got 2 different flavors of challenge, and it lets us know that meeting these can be hard and not often possible to do in one solution. So that from these, we're looking for multiple solutions for each exercise. I think that's really nice. And then we get both lights indicating that's done.
Oop.
What's happening over here?
We lost the game there.
Huh? Oh.
Looking at Steam now.
Now you can look at my Steam library. Cool. The Zero advocacy community felt the previous assignment was not inclusive. This time, send only the zeros to the outbox. What happens to the other numbers and letters? Management leaves that detail up to you. They get thrown on the floor. So now I want to pick up a number, and if it's 0, I want to jump to outbox.
This one's pretty weird. I did this last night, so I'm gonna watch you struggle a little bit.
Okay, yeah, let's do that.
Because I struggled last night.
Yeah.
No, I can't.
All right, so we pick up a number, and we're gonna check if it's 0, and if it's 0, it needs to go to the outbox. So this jump needs to do something. What actually happens if we start with an outbox?
Oh yeah, I don't know.
You can't outbox with empty hands. Okay, perfect. All right, so we'll grab something from the inbox. Go ahead.
I do think it's interesting. So, like, when I was playing this, I kind of thought they were going to give us a jump if greater than 0 or something. Like, I thought they were going to not make you do this, but they did. So I thought that was pretty interesting that they chose to go with the more assembly true solution versus the I guess maybe it builds into future puzzles, and that's probably why. But
yeah.
It's pretty interesting.
What do I don't even remotely know what I want to do.
I think you're going to have to, if I recall, you want to, skip the outbox, basically.
Yeah. Yeah, which, makes me want to do... So if it's 0, I guess I want... So inbox, or skip the outbox, and then if it's 0, go back into here.
Oh,
then I need to jump back up. That's jank.
Oh, that's
I think
hilarious.
You
did it. That makes sense. You did it different.
Oh, I've done something wrong. Oh, because then I'm jumping. I'm getting stuck in that jump. Okay.
So
it would make sense. Yeah.
Yeah, I did the opposite where I skipped a jump instead of I skipped the jump that leads past the outbox. If that makes any sense.
Wait, so you had jump of 0 here. But we need the jump of 0.
Yeah.
How do you skip this?
I put the jump in the middle of that jump of 0 clause. Like the next jump, not this jump. Okay, put that one back. Put the outer loop back.
Okay, so jump of 0. Wait, what? This is the part of the stream where my brain stops working.
Put that jump back as the outer loop again. You need another.
Cool, like that.
Another
yeah.
Yeah. Okay, so now get another jump, and you put it in between the jump of 0 clause.
Got you.
And then you jump it past the outbox. The output of it.
Perfect. So jump of 0 then skips... Oh, sorry. Great. Yeah, jump of 0 then skips this jump. Great. Makes sense.
Yeah. Which is basically what you did, I think.
Yeah, I just had them in the wrong order. Psych, you are dropping knowledge bombs today. GUI to answer the puzzle is very convenient. You can quickly create a program and solve the puzzle like a Parsons problem. Yes, if you haven't encountered a Parsons problem, that is when you give people a code problem with the lines of code out of order, and you ask them to order it to make a coherent program or to make a program that does a certain thing. And yeah, you could easily use this GUI to do Parsons problems. Okay, so this is a slow solution. Oh, no. How would we do that for the speed?
How slow were we?
We were 7. Too slow.
How is slow measured? What does that mean?
It's the number... I think it's the number of steps. One sec. Oh, wait, I don't need to... If I just click on that. Oh, no, I can't see the stats again. That's very annoying. Measures number of commands your program must execute before it finishes.
I see.
Oh, I didn't realize we had other tabs. That's cool.
Oh, yeah.
Alright, so... Oh, but then we don't loop
There's
at the
no
end.
outer loop. Yeah.
Yeah. How would we do it in less?
How many steps do we already have? What's in our old solution? How many steps are in it?
1, 2, 3, 4, 5. I wonder if it's going to be involving copying 2.
Well, actually, so we did get the minimum step count, though, yeah? Like instruction size. So it's more about cycles?
It's more about number of cycles, yeah.
I don't know if it's... But cycles meaning
Hang on,
instructions executed, right? Or...
Yeah, so it's number of instructions executed. This is this other jump that's always the problem. There's no way of yeah, that's not it. Interesting. No, I need to leave it alone. We can't spend all day not solving that. Do you like spaghetti programming with all these jumps? Yeah, I mean, this is an interesting thing. This is like the peak problem with like what you call like ball and string programming, or like the node programming, where like you have nodes that are joined by lines, which is a really common paradigm for visual programming, is that whenever you have nodes and lines, and this isn't quite that, like the line is just a visual representation of where the jump points to, but whenever you have nodes and lines, it does really quickly turn into spaghetti.
Yeah.
And yeah, it's a very popular programming paradigm. Like Unreal Blueprints are nodes and lines, for example. NAN is nodes and lines.
Are there other visual paradigms, though? Like,
yeah,
what is...
there are. Scratch, blocks, blocky snaps, snapping blocks together.
Yeah, I guess so.
I
mean, that has a different problem, but
yeah, well, no, I mean they all have problems. Yeah.
Do you define blocks in Scratch, like with Scratch? Does that make any sense? Like, can you make functions?
Yes, you can make functions. Yeah.
Okay.
Yeah. In fact,
that's like usually the answer to this in real programming. Or
yeah, give me a sec.
That way. I mean text-based programming. Because yeah, my limited like node, or what were you calling it? Ball and string, or my limited
ball and string. Yeah,
ball and string style of thing is things get out of control because there is not really an easy way to create functions really, and like architect it. Maybe
so there is this is Blockly, not quite Scratch, but Scratch is built with this, so like we can. So you have different types of functions. So this one doesn't have an explicit return, and then this does return something. So you can slot a variable into the return, and then we can like throw some logic in, or we can throw some stuff in here. So let's throw math in there, or we can't. Why? Oh, it needs to go into return. There we go. And so I need to take some parameters, and this I really like. You snap your inputs in, which I think is really cool. Then I can get at those for the return. So I've given this function 2 inputs, x, y. And one of the really nice things about Blockly is it makes like documentation kind of like first class. So like this is the name of the function, but it's like a thing to do something, so you end up describing it more than just like naming it. But then then I can reference that function. So here it is, do something, and it's got the 2 spaces for input. So yeah, it's pretty neat. One I don't know if it, I guess it's still going. There's a visual language called Enzo, which does function definition. It's like ball and string, but it does function definition. Basically, like you grab a collection of nodes and then you just collapse them together, and that then makes a node with a string input and output. Yeah.
Yeah, I was looking at so amusingly, this actually comes up for me a lot in Factorio as a place where I see this, because you have this thing where like Factorio is pretty cool because you're like optimizing these problems, and then you get to the point where you're like, oh, there's just like a billion variables on the screen. I can't even hold this all in my head. And like there's a particular mod called like Factorismo or something, where you just like take some amalgamation of normal factory blocks and you just stick it inside of like
like a compound,
a box, a compound, and you just like place that around. It was interesting. That's really cool. Oh yeah, functions are why this game like falls apart for me when you get too big. Because you're just like, how can I think about this?
It's that's really cool. I think like everyone. I haven't played Factorio, but I played a lot of Satisfactory, which is obviously like basically the same game. I think everyone goes through that stage of like, oh, I have a factory here that takes a raw resource and does a certain chain that's used for something more complicated, and now I need to duplicate that at some point. And I think lots of people realize that, and then they don't quite then make that next step to like single units that you then compose in a kind of programming thinking way, just because the game doesn't facilitate doing that. Like there's no way to do that bulk copy and paste maneuver and like have a single input and output.
Well, and what's interesting too is that Factorio, and I think Satisfactory is maybe there's not blueprints in Satisfactory, are there?
Not yet.
Yeah, so like Factorio's solution to that is blueprints, but that's also only half. Like as anyone who ends up programming for long enough will learn, when you start with a template, it's great until like you realize you're like 80 versions behind, and like the template has a lot of things that you don't have anymore, and you're like, oh no. And so I think that's always interesting, where like it has that first level of like, oh, the blueprint solves this, and you're like, sort of, like it's pretty interesting.
Syke says, I hope you try again Blockly programming Twilio Quest soon. Yeah, we've had a couple of goes at it. My big problem is it would be very easy to do now with Ryan's lovely React pop-ups, but I still don't know React. I've learned some React now. I mean, so I've never run it. Okay,
it's literally just opening an iframe. You can just do whatever you wanted. Yeah. But the bigger problem, I think, is going to be like making that. Well, I guess that's actually not a huge thing. Never mind.
What? Making what?
Sorry? I was just going to say like the engineering. To make that a smooth experience is more the thing that I'm worried about versus the like making it function, period.
Yeah, where you put the code is a good problem. So like I think the way we could do it, if we wanted to do it like naively now without adding anything else, I think you'd pop the React window with an iframe that's full screen of Blockly workspace. Yeah. That Blockly workspace would generate JavaScript, and I think you would have that JavaScript get dumped into a example code file that's opened in the Quest IDE, and then you just go run that. You just go into the objective and run that code, and I think that would be the best way to do it with the tools we have.
You can reverse generate, right? Like you can take the JavaScript code and generate Blockly.
No, it's not that clever.
It wouldn't be that bad to store the Blockly file next to the example. Like
it's just a big block of XML.
Yeah, we can just store it next to it. Yeah, so it's definitely doable. It's just a question of like, I don't know how because like my experience with the Blockly workspace is that it's like a little janky, and it's like kind of hard to, at least configuring it to set up nice. Like I appreciate what Scratch has done to make that feel good. Because
for some reason, Blockly makes the bizarre assumption that everyone using it wants to define their own blocks, and they make it really hard to actually find like all of the pre-built blocks. There's no just like, here's the workspace you need to have a fully functional like programming environment. You have to go piece it together from their demos, which is
so more than anything else though, like the visual piece is also cool, but I think like the really exciting part about if we got to use Blockly would just be like, because we have this problem where like this game is able to say like, now try one new command and don't think about anything else, and we're just like always the entire time is like, here's everything in the entire JavaScript ecosystem, good luck,
right?
You know, like with Blockly we can keep introducing blocks that way, and that would be pretty interesting.
Yeah, for sure. Cool. Okay, now we've got subtraction from each inbox. For each two things in the inbox, first subtract the first from the second, and then put the result in the outbox, and then subtract the second from the first and put the result in the outbox. Repeat. Subtracts the contents of a tile on the floor from whatever you're holding. Okay, so the first from the second. So we need to take... How do I get rid of this enormous note?
You did it somehow last time, and I was like, I didn't know you could do it at all. Is it the question mark in the bottom left? What's that? Below jump of 0? What's that do?
Oh, that's cool.
Oh, that was not what I thought that feature was.
No, that's very understated. Okay. This bizarre how much this is messing me up. So, the contents are tile on the floor from whatever you're holding. So the first one is subtract the first from the second. So I need to put the first one on the floor, right?
Yeah.
Cool. And then pick one up, and then do subtract 0. And then we need to put that in outbox, and then we need to do it the other way round. So I need to copy from 0 and then subtract from 1 and then put that in the outbox, and then I need to jump.
You need to copy to 1 first. You're subbing 1. You never put it in.
Oh, yep. Copy to 1. Okay.
Oh, I guess it just scrolled away last time.
Yeah, maybe.
And we just didn't realize it.
Yeah. Oh, now I've done it because I'm holding another. No, hang on, that's correct. That's fine. Okay.
I think you're.
Okay.
Yeah, I think it was okay.
It's possibly the wrong order, but we'll see what happens. Now, I'm not convinced this is going to be optimal in any of the dimensions. Okay.
What about every dimension, Joe?
Every dimension. Check me out. I'm a human resource machine.
Woo!
Okay. Ooh. Hang on a second. Oh. Awesome. Okay. Where do we have a little gaggle of scientists here now?
They're friends.
What are they doing? Did I miss some... Ooh, optimization.
No, I don't know. I was confused by that too.
Get 2 things from the inbox. Oh, is this comments now? Oh, that's cute.
Yeah.
I like that.
Just drag it off to the left to get rid of it.
Okay, yeah. Get 2 things from the inbox if they are equal. Put one of them in the outbox. Discard. Oh, I see what we're doing here. Fine. Implementing our own equal.
Yeah. This is the kind of stuff where I'm like, oh wow, because you could have just given the equal command.
Right. Yeah.
Jump if equal is like assembly, but they've made it a puzzle instead. So what I think will be really interesting is if they give you a jump if equal command later. Like that would be an interesting choice. I don't know.
Well, what would be even more interesting is if they give you the ability to create functions and they ask you to turn this into a command called equal.
That would be pretty sweet. I don't know if they do that,
how many levels? Oh, hey Kit, welcome. How many levels does the game contain? I don't know. We can have a look at the tree again in a minute, and you can add them up really quickly. So this actually does call back to probably my favorite part of my computer science degree, which was so the university I studied at was really into functional stuff. Like all of my modules were Haskell and this kind of stuff.
Nice.
So we did the lambda calculus pretty early on. Have you encountered the lambda calculus? Okay, so it's like, you've heard of Turing machines because we've spoken about that game about Turing machines.
Yeah.
So Turing machines are one of the base models for how computing works, one of the abstract models for how a computer works. Lambda calculus is another one of those equivalent early models. And basically the lambda calculus is just a way of defining programs using only application and composition. So you don't have anything else. So if you imagine a programming language, and you don't have anything else except the ability to apply something to something and to compose 2 things. That's the only operations you have. And so you just have in practice, you just have a lambda, which means application, and then you can chain things. And so one of the things you do with that is see how you implement all of the other primitives. So from just those 2 things, you see how you implement numbers, and numbers are basically counting successive applications. So if you have a lambda and you give it a lambda on its own is 0. If you have a lambda and you apply another lambda to it, that's 1, and then you keep going and that's 2. And then booleans, you see how you implement truthy and falsy values, and you end up with this absolute horror show of just the bare minimum language. How do you build it up to implement the basics of computing from this really simple mathematical model? And that was one of the things that I found really, really interesting. This kind of reminds me of that in a very much more practical sense.
That's cool.
I don't actually need to copy here, do I? I just need to subtract.
Yeah, I believe so.
And then now we've got that stupid situation where I need to jump to an outbox again.
Yeah. I don't know what the better solution is here. If this is technically not optimal, I don't really know how to make it better.
Jump is 0 to outbox. I mean, never jump at the end. I just hate this double jump. I really think that's horrible.
It does. It is weird.
Yeah.
Oh, you've done the.
Do I? Yes. Cool.
I did that too.
So I need to pick up the number again. Sub-0
Yeah.
jump if 0, copy from 0.
Yeah.
And it's each pair of numbers.
Oh, hey, Silly.
Discard non-equal pairs. Hey, Surly.
Yeah, I agree. That was actually my. You missed this when they introduced the jump command first, but I actually thought it was going to make our like little character on the screen jump for half a second, like just jump.
But then you could argue that go to would be like go to a certain location on the
That's
map.
fair. Yeah, I guess there's never a good. This is always going to be slightly weird, but
I think the word the go to has forever been ruined by go to considered harmful. You just can't use it if you're doing a language of a go to construct in it now.
Well, yeah, I love. We just do. My favorite is like labels. Like,
Yeah.
it was really fun. Like, yeah, like when I was learning it, like in university, like pretty early on, they were just talking about how horrible GoTo is and it's terrible. We're going to use this cool language called Java instead. And then you're like, what are these label things? And they're like, don't worry about that. That's not a GoTo.
Yeah.
That's a label.
I actually think in ARM assembly it might be jump.
I think it is.
And I'm only saying that because I
guess I don't know which variant of assembly I used, but the assembly that I used was jump.
Yeah, I'm not going to be able to find like the. I'll learn about the instruction set. There we go.
AMP, right? That's what I remember.
Oh my god! Just give me the instruction set. Okay, never mind. Yeah, it's J. I think definitely think it's JMP. I think that was the ARM assembly I learned.
I think O2 is like a C thing, like specifically the word go to.
Right. Maximization. Oh, we were one command off on that one.
Yeah, I don't have a good way to think about the speed. I'm sort of like I kind of get it, but I'm sort of confused by it.
The accounting department has determined that treating all numbers equally is no longer profitable. This is where we kind of get into this game and gets a little bit too real.
Yeah.
Management wants the big numbers only.
This is from this is a slightly older game, yeah.
Well, I just mean also just on like, you know, it's parodying a terrible company, and management is like all for equality until profit, right? Like,
yeah, well, I think in 2015 when this was released, it was like slightly more haha funny, and now it's like
now it's just like sad.
Yeah, you're like back when Human Resource Machine was making fun of this, we were like, oh, we'll probably fix it by then. And then
grab two things from the inbox and put only the bigger of the two in the outbox. Then I get jump if negative. Again, this is a funny one. Where like they don't just give us the comparison operators, they want us to do a mathematical operation on it and then see what's left. So we're going to grab one, copy 2, 0, then we're going to grab one, and we're going to subtract. Oh, yes, we're going to subtract. I guess we'll copy 2, 1. We're going to subtract, and if it's negative, then that means the one in our hand is bigger, so we go to outbox. If it's not negative,
I think this is where I closed my phone last night.
if it's not negative, then we copy 0, and then we go to outbox, and then we jump to the top. I'm pretty confident about that.
I believe you.
Oh, nope, I've done that wrong. I need to copy from again on this negative.
Yeah. You
Copy from 1.
Yeah, that makes sense.
Yeah.
This is definitely where it starts getting like messy.
Why did I get...
That was weird,
Yeah.
but it worked. It was visually odd.
That's not correct. Oh, it's correct. Why am I getting that extra copy? Because it should be jumping of negative. I shouldn't have that copy. Oh, I'm doing the sub. Okay. Oh, wait, hang on. If they're equal, just pick either one. Okay.
Right.
Why do I get that extra copy? Now, this is cool. This is really cool. So your solution works for those specific inputs, but it fails on other possible inputs. I'll give you some that cause it to fail. What causes it to fail? So 8's the bigger one. Oh no, I get 1. Okay, there we go. That's our problem. So let's step through. Okay, so this is one thing I noticed. It randomizes the input every time, which does make it really annoying if you stop and reset. So we're at sub 0.
Still be the issue though, yeah.
So now it's negative. And I copy from 1. So I just need to swap these around. Oh, I see what I'm doing. I'm always copy. Okay, I get it. So if it's not negative... Okay, brain is broken. So we get a number, we put it in the thing, we get another number, we subtract it. So we're subtracting the one on the floor from the one in our hand. So if the one on the floor is bigger, we're then negative. So we jump and we get the one on the floor. If we're not negative, we get...
I think copy from 0 needs to be...
Yeah, it needs to be there, and that jump...
Yeah.
That
the jump needs to go over something.
Yeah.
Yeah. Well, now your jump is... Your inner jump is...
Pointless,
a bit redundant.
Where do I want that to be? Right, so jump of negative, I want to get the copy 0. That needs to be inside.
Negative, you're going to do both right now.
Yeah, that needs to be inside. And then that needs to be... No, because we're always going to do both. No,
I think
there,
jump...
okay. Yeah, but then we always do both if we do the negative. I just need another...
No, you don't. If you're negative, you jump past 0. Because you're going to run the jump internal to the jump if negative.
No, but we're going to copy from 0 and then go on to copy 1. So we need like a whole other... like that here. We need to terminate the program here.
Oh,
rather than going on and doing copy from. I'm sure there's a neat way of doing it, but I want to make sure that works.
Yeah.
So this one's bigger, so subtract. So we should pick up that one, go to outbox. Yes. Okay, get this one, write it. So that one's bigger. So we subtract, grab that one, go to outbox. I think we've got it.
You can tell it's serious when we're both just like
we're leaning inwards, yeah.
Looking at the screen.
It's now a forehead stream. Okay, we've got some fixing to do here. Oh, okay, we're rough. We're rough. This one, I think we haven't got Eva or me to work on it. Okay. So, do we maybe not even copy? What happens if we try and copy from an empty register, do you think? As in, like, if I do that...
You could send either one to the output, right?
Only if... Oh, yeah, we still need to keep track of it because we've subbed, right?
Yeah, you're going to ruin whatever's in your hands.
Yeah. Oh. So it's definitely this spaghetti mess here that's the problem, right? So we sub one. So we sub them, and then we want to get one. We want to get 0 from the floor. So we jump and get 0. Otherwise, we want to get 1. So we need, like, some better way here.
So if you're 0, if you're not negative, we want 1, right?
Yeah, so I think that.
Yeah. And then the outer one, but
Yeah.
so that I think makes sense.
So jump if negative, just get 0. If we're not, then we jump over the 0. Yeah.
Yeah. So like 0 is the negative one end.
Yeah. The part in the stream where this transitions from like us talking about how the game is made and having what?
Oh my gosh.
And having useful insights to just like actually getting stumped by the game.
Well, we got we got 2 instructions shaved there. Interesting. Okay, I don't know what you cut now.
I think it's that inner jump somehow.
Well, maybe jump if negative or jump can jump to the top again, and we cut the outer jump somehow. I don't know how.
No, because we always need to go to the outbox, right? Both need to go to the outbox. I think it's probably something in.
Just do the copy from first. Like you copy from. Like we don't.
You're always holding. Well, you only need to conditionally skip one of those if one is true, right?
Yeah,
like,
exactly.
So we do copy from one. Sorry, hang on. So
or whichever one.
So we'll copy from. We always copy from 0, and then if it's negative, we skip the copy from 1 and we go straight to outbox. Yeah. Otherwise, we go. Yeah.
Yeah, that'll get 1 out. I don't know if that's gonna be faster. I guess it's faster, right? 'Cause that's fewer checks. Did we do it backwards?
Possibly. But then the rest of it, I think, is fine.
I think the logic is sound. I honestly didn't even bother to think about whether it was 0 or 1. Oh,
right,
man.
such a step for it. Now we actually have to check. Okay. So 3 goes down. 7 goes down.
Positive.
So it's positive. So we copy from 0. It's not negative. So we copy from 1. And we go to the outbox. Great. So now -3 goes down. -7 goes down. Oh, this is going to be the case where it breaks. Or maybe not. Because it's negative. No, it's fine. Okay. I think it's going to break in the case. I think it's going to break in a. I don't know. And then that's.
I have no clue what breaks it. Because it doesn't matter which thing because they're the same.
Yeah, I think it breaks in the case of multiple negatives. If the lesser negative is in the first slot. That's my theory.
Oh, I get what you're saying.
Oh no, it breaks there.
Wait, what?
So 2 is the larger.
I think this is actually kind of what you're saying, though.
Yeah. So 2 is larger, so we copy from 0. But we're not negative. Oh, sorry, we are negative. Wait, why are we negative?
Oh, we copy, and then we ruin when we copy from 0, we ruin our negative check. We need to check that we're negative before I think we have to do it backwards.
Yeah. Or... Yeah, we do.
Oh my god, yeah, because we copy the positive.
Yeah.
Oh,
so...
Okay.
So we need to do that check first. Yeah.
You write the easily read function.
So what do we have? We copy to 1, and then we get... And if it's negative, we want to grab... Yeah, then how do we skip?
I do think this is a particularly interesting thing that programming games love to do. That is something we don't really want to encourage in TwitterQuest is this optimization thing. Because it's like, this makes you write air quotes more optimized code, and like one of the first things you unlearn when you come out of university
premature optimization
is to like stop optimizing stuff.
Well, like code golf is super fun. It's a super like great
fun.
activity to get you thinking about programming. But like from our perspective as like a practical programming game, we're like, don't reinvent the wheel. Use these libraries. Build on top of like stand on shoulders. And then there's like, and this is kind of why we have Type and Forge, right? Like we have this space, but it's elsewhere.
Yeah, more people are going to read your code than spend more. Or what's the? I don't remember the numbers, but it's like more hours will be spent reading the code you write than writing it. So like optimize for that. You know.
It's going to annoy me so much. Ryan, we need to solve this.
No, yeah, I know. I just was like thinking about it and was like,
no. That wasn't me telling you to shut up. That was me looking at the time and realizing we've got to finish thing.
Okay.
So we need to do that jump of negative check, and so what's in our hand here? It's the result of subtracting these two, right? So it's the result of subtracting 0 from what's in our hand.
Yeah.
Okay, so it's the order around we do this. I think we want to copy from. No, because that ruins the negative check. Yeah.
You have to do the negative check before you copy anything, but I don't know how you. Because if you.
Because now, even if we do this, we still copy from that one. So how the hell do we reduce this instruction then? Because this obviously wasn't the way we reduced the instruction, but I can't think what else. Do you think I still think it might be the extra right? I don't know. No, it can't be the extra right because we need to put that thing.
Right. Yeah. It's very interesting. So if you're negative, you would output the right one, which is true. So like this fixes the case we just hit, but I think this breaks the other case. Is that the issue? Because like,
I mean, this will always break if yeah, right? if it's not, yeah, you're always going to be copying the one from one.
Interesting. Yeah, I'm not sure how else to remove an instruction. I want to like store. That's going to add so many steps, though. Is the thing? Like
we're trying to
store the computation, but then you're gonna have more steps.
Yeah.
Interesting.
I wonder if this is one. Is this? So I want to test something. Now that we've got those instructions, what happens if we go back? We only okay. So we are meant to just do it with the instructions we have right now.
Oh, like a later instruction lets you optimize in a. That's Zachtronics. Well, no, Zachtronics doesn't do that. Anyway,
Kit says, "Are you able to create a third box to compare against?" Do you mean like so we've got free? We do have free slots to save it, which is interesting.
That is true. I think so. The thing that we're optimizing though is. We had 11 instructions in our solution, and we removed 1, so now we're at 10 instructions. So I don't know how we could make use of the third box.
Well, let's try that solution, because it might take us down a fun place. So, like, okay, let's say...
That could be the fast solution.
Yeah. So say we grab 0. Sorry, we grab an item, we write it. We grab an item, we write it. We subtract them. Then at this point, we need to do the negative thing. But what are we then doing then? Well, we're going straight to... We then need to pick up the... So, sorry, we've got one in our hand. We're currently holding one.
The result in our hand.
Yeah, we've got the result in our hand, but, I mean, what was that? What were we holding when we did the subtraction? We were holding 1, so we're subtracting 1 from 0, so if it's negative, 0 is bigger. So if it's negative, we need to copy from 0. Otherwise, we need to copy from 1. And then this is the problem that we have here, is that we need this jump.
There's nothing in 2 right now.
That was an error, I think. So we need this jump. And then this is the solution that's 1 too long, right?
Yeah, I believe this is our original one.
Yeah, 1 too long.
1 command less. It's fascinating. Yeah, I'm very unsure. I mean, I think we literally have to do steps 1 through 4 and 5. Like, I don't. Is that wrong?
There's no other way of comparing these two numbers that we're missing, right? So, but the point about what's in your hand, are you already holding an output, or can you not copy from what you're holding? You can't copy from what you're holding. Copy from has to be one of the elements on the floor. And the problem with what's in our hand is once we sub, what's in our hand becomes the result of the subtraction.
Ooh.
Go on.
What if we add? Can
add
we
it
like
back? Can we
what if we add it back or something, and then we don't need to store it or something weird like that?
So if we remove,
maybe there's math that can happen here.
Yeah,
That's
no, hang on. I
don't
think that's
just say
promising.
maybe
So,
math
okay, let's say we do it at 0. So let's remove the copy
2
to 1. So we get 0, we put it on the floor. We get 1. We subtract 0 from 1. If 0 is then bigger, that will be negative. So we jump to copying from 0 and we go to outbox. If it's not negative, and I think I know where this is coming in. If it's not negative, we add 0, and then we copy to 0.
Oh, interesting.
And then we're always reading from 0, but 0's now the size of the thing.
Strange. So you undo the calculation and save it in the same spot, and
then save it in the same spot. Yeah.
From 2 different places. Yeah.
Nicole, you're a genius.
What?
Oh, and the speed. I'm not even thinking about it. We've done the size. That's all that's bothering me. Okay.
I think there you probably.
Yeah.
So that's got to be more about like caching. That's probably more in the direction we had before.
Mm-hmm.
Man, yeah, that's interesting. It's math. You just wave your hands and say math.
And you know why that particular optimization problem is really interesting is because, so it optimizes on a couple of verticals, which is really interesting. So it eliminates a jump, but it also eliminates a saving. It eliminates a saving spot. It eliminates a register. So the whole reason we had these jumps was to selectively choose which place we were copying from. And we optimized that away by only copying from one place. And then the mechanism was, how do we only copy from one place? Well, it's to make use of math to add back up and make the value in place. And that is like, from the perspective of like this, imagine this is an assembly paradigm. That reducing the amount of registers you're using is a really actually practical and useful assembly problem. Like, we were talking about like in real life, you tell people not to optimize, but if you're writing assembly, the amount of registers you have is actually a practical problem, and is worth optimizing if you're trying to do something that requires more registers than you have. So that is actually quite interesting.
I run into this a lot when I do Zachtronic stuff too, where it's like I've trained myself at this point to like explicitly not do stuff like this because you have to look at this and be like, what? Because what we have written here is not immediately obvious like what we're trying to do. We're doing like a subtraction and addition, which is like what we actually want to do is pick the greater one, and like this doesn't look.
But like I think part of the reason why that's weird for us is because like when you're programming in a not to get into these stupid, into a high level language, it's abstract from the resources. And so when you're optimizing that, you're not actually doing that with any goal other than just reducing the number of lines or the number of things you call. Like, it's all like vanity metrics for optimization, right? Whereas this is like imagining computing where you literally have a limited amount of space. And you're reducing that, and that's just not a way most of us program now. So it's really weird for us because like that optimization would be meaningless, but in context, it does make sense. It's really cool.
That's where I always think about when I play like Zachtronics games or stuff like this, where it's like this is invariably the thing that trips me up. Is like you have to like because what we had to do here was explicitly stop thinking about it the way that we would think about it in a traditional sense. I say traditional in a way that is totally meaningless. The way we normally work day to day. We like explicitly break that and then do a weird thing. Which again, like you're saying, is really weird because of our context.
But this is where I actually think 7 billion humans does us slightly better, which is like so having now optimized it and found out that the optimization solution was in reducing the number of registers, or like the number of the number of memory used, it would be far more interesting if that's how the game stated it. If it said find a way,
Right.
if like the optimization problem here wasn't find a way to use less commands, but was find a way to use less spaces on the floor, that would feel more intuitive. The goal would be more obvious, because like we were trying to work out which command we were removing, right? Whereas if you had said find a way to use less space, it's obvious that we need to find a way to get rid of a copy too. And so that, I think, is something that's holding this back a little bit. And I think 7 billion humans actually does that a little bit better, because the way that machine is designed, with the many people. And we'll look at 7 billion humans in the future. I think that's a good note
yes,
to...
we are definitely not doing that in 6 minutes.
Yeah, no.
But yeah, I do think that that's an interesting side effect. I don't think there's anything wrong with this kind of puzzle. Like, this puzzle's genuinely interesting and it's cool, and I'm like remembering and learning things about assembly. But I think there's a danger in something like putting this kind of thing in Twilio Quest, where it's like, I don't want to accidentally train people to use single letter variables that do math in place and like
we would have to put it in context, optimized. Right? Where we would have to we would teach people like, hey, there's a thing that some people do and it's called code golf, and this is why they do it, and this is what it is, and this is some of the things you do. You don't do this in real code. And we would have to put it in that context, which I think would be fine and good.
No, I think it would. Yeah. It's just interesting to think about the context of this. Where because coming into this, I look at these blocks and I'm like, oh, this is like a great learn how to program game. And as I'm thinking about it, I'm like, sort of it's good in some ways, but I guess it's still good for logic. Like the logic here is the important part, not the.
There is actually a context where, thinking about it now, there is an optimization problem that could be practical to do in Twilio Quest, which is serverless. So you are running an application in someone else's you're writing JavaScript for someone else's restricted runtime. You don't have X things you're used to having. You are trapped in X version of Node.
Oh yeah.
That is actually like maybe one way of getting at this, like making people rewrite code they're used to writing in a different way kind of thing. Obviously, that's then really heavily tied to like a certain. I mean, even actually, like Twilio functions are still we just bumped a major version, but it was from like 12 to 14. Like we're still like 8 major versions behind or something. 4 major versions behind. Cool. Ryle, no one's going to be complaining about Hungarian. Sorry, no one's going to be defending Hungarian notation on this stream. Alrighty, so. I think that's a beautiful place to end it. I think that gives us at some point in the future we'll definitely have to explore 7 billion humans. I really like this game. I think it's
good,
yeah, it does a lot of really interesting things, and it's again the range between the ways in which these puzzle games that use code, the extent to which they're educational or not. I feel like this one is almost explicitly educational in terms of like computational thinking, because it is not necessarily aimed at people who already know code as much as some of the other games we've looked at, right? Like
I do think that's interesting, where it's like this one is almost using code explicitly to not teach. Like it's explicitly not teaching code. Like it's trying not to. It's like which is interesting, and like a fundamental prereq to like to getting into code is understanding those thinking patterns. So
for sure. Cool. Alrighty. Well, we will see you all next month. Just a reminder, we are always Press X to Learn is always on the second week of the month, so we will see you again in the second week of September. Next week, is it you or me? I always forget what's on the third week. It's the dev stream, isn't it?
I feel like I just streamed, but I guess that's not.
You were on the art stream, is why.
I am streaming once again because I was with Carrie last week.
Right.
We're here every week.
Yeah, we are here every week. Third week in the month is Ryan on the dev stream. So you'll see Ryan again next Tuesday, 3 weeks in a row, and you'll see me on the fourth month of the fourth week of the month for our for continuing on building dev fundamentals. also working on whatever dev fundamentals thing I'm working on at the time. So thank you all so much. Thank you for watching. Thank you for participating. Thank you for watching us lose our minds over that particular problem.
The forehead stream.
The forehead stream. Oh, that's a really great way of putting it as well. That's if we ever make a logo for the show, it will actually just be like a shiny forehead in a webcam viewport.
Cropped, poorly though.
Yeah, cropped like yeah. So yeah, we'll see you all later. Thank you so much. Bye.